welcome to the third session of our live OC preparation series. Before we get started, we'll just quickly go through a couple of housekeeping items. Now, to introduce myself, my name is Anderson. I'm a North Sydney Boys graduate, and I've been teaching OC and selective preparation for half a decade. So I'm glad to be here with you all today, and thank you for joining. For those who are not currently an Alpha One student, we are now open for enrollment for our Term 3 classes, and we're offering a free trial class for new students. To book in a free trial with us, you can submit a form on our website, or you can contact us via phone, email, or WeChat. We're also running an OC holiday program next week, so feel free to contact us as well as if anyone else is interested. Finally, this is a webinar, so all of you are muted for the time being. If you have a question, you can type it in the Q&A down below. There's a little bar, and it's titled Q&A, which is the icon with two speech bubbles, and the webinar moderator or myself, the webinar moderator will pass the question on to me, okay? Now, one final thing as well, guys, is today, as I'm going through the paper, I'll be writing down working out as well. And there's going to be tips and tricks written on the board as well. Now, if you guys feel like the writing's a little bit hard to read, or if you feel like just we're going through the working out too quickly or changing onto the next question too quickly, and you missed out on the working out, that's fine. This session will be recorded, and we will post the link to you guys to access this recording via YouTube. Okay, so don't stress if you don't get to write all the working out down or you don't get to see all the working out. If you want to check, we'll have that link sent to you guys, and you'll see the recording on YouTube. Okay. All right, with that in mind, let's begin. So I'm going to share my screen of the paper, and I'll be writing down my working out and going through the questions one by one on said paper, okay? All righty. Okie dokie. All right, everyone. So this is the paper, right? Make sure you have the exact same paper. Now, if you, I'm trusting that you guys would have had a chance to go through this paper or make attempts at it. And if you have any specific questions about, say, question 5, you tried it and you didn't know how to move on from one step, or if you had no idea how to go through it. So just stick around and I'll go through that question. But if you still don't get it, please let me know in the Q&A section, right? And then the moderators will let me know to go through it again. Okay. Alrighty. So we'll move on from here. So starting off with our first question. Oh, by the way, guys, there's 35 questions in this, okay? Now, if you feel like I've gone through all the questions already, and you're cool with heading off, enjoying the rest of your school holidays, feel free to hop off, right? Because this session will be recorded anywho. So you guys can access that video again, or this recording again. But if you want to stay, even if all your questions are answered already, there'll be some tips and tricks that I might be passing on to you. And if you don't know how to apply them, you could ask me in the Q&A. Okay, so it's up to you guys if you want to hop off and just relax, or if you want to stay the whole way, because there will be a recording for you guys. Okay, ideally, if you stay, you can ask me some of those questions. All righty. All right, so starting off with question 1. Now, from this question here, when we read it, first off, you'll notice that the diagram is the easiest one to see, right? But don't assume questions. Now, a lot of students, they see a diagram and they automatically assume that it's going to be about one kind of topic. All right, or it's going to ask them to do a specific thing. Now, if you haven't read the actual question and the words, we won't know. So don't go assuming things, okay? You see a diagram and you see grids, you might be thinking, it's to do with shapes and turning or reflecting shapes, right? But while that may be true, there may be another topic inside, right? So you got to be careful and read the whole question. So you have an F shape that's made out of squares and is shown on that grid below. They actually shade it to make that shape. How will the F shape look after it's turned a quarter of a turn anti-clockwise? Now, there's going to be keywords every time you deal with these kinds of questions, with your math questions, that indicate a topic to you, right? The first thing you always want to do is look at what the question's asking for and break down any keywords that bring out any topics. So when we think of turning, right, that brings out the topic of rotation and transformations, how you can transform an image or a picture or a diagram. And those transformations could be reflecting. It could be shifting its position, right? So it still looks the same, but it's just moved in different spots. And you have rotation that turns the shape and changes the way it looks, right? Now, in this case here, it only said turn And so there's no other kinds of transformations involved. Then you have something called a quarter of a turn. Now, turns in just tell us how much is it going to turn. So quarter, half, full, right? A full turn means you go all the way around in a circle. So it stays the exact same way as it looks right now. A quarter of a turn, right? If we think about our compass, right? And there's 4 quarters here, it means just moving 1 quarter. So 90 degrees, okay? Now you got how much you're turning, you got the fact that it's turning. The final clue for us is anti-clockwise. Clockwise and anti-clockwise. It always tricks up some of our students, right? How do we know which way to turn? What's the direction? Now, you can think about a clock, the clock in the name. So the way that a normal clock turns, which I believe, so if we draw out a little clock or a circle, it goes from left to right, right? Now, so left to right, okay? Now, when we look at anti-clockwise, which is what the question's asking for, it's the other way around. It goes from right to left, right? Right to left, not left to right, right? So think about how the hands in a clock move. It will help you think about what direction to turn, all right? So anti-clockwise, we're going to see, all right, the shape turn in the direction opposite to how a clock moves. All right, now let's apply that to our diagram. Now, how do we do this? Right. Sometimes you might get a more complex diagram. So F is quite complicated, but you might have an even more complicated one. So how do we deal with those? I like to think about this technique called tail and ends. Tails and ends, right? Or it can also be called points of interest. And what that means is you're going to identify certain parts of your diagram that you're going to actually picture turning. You don't have to picture the whole shape turning, just certain points moving to certain new places. Right? So here's an example. If you have this side, you give this side at the top an arrow pointing a certain direction. If you were to apply a quarter of a turn now and in the opposite direction of a clock, right? In other words, moving right to left, right? This hand, if it moves a quarter of a turn or 90 degrees, it's going to now point to the left. And the arrow that was pointing below at the tail of the F at the bottom, if it moves to the right, it's now going to point to the right, right? So what shape are we going to end up with? If we scroll a little bit further down, you'll see that E would be our answer. Notice how the arrows, right, have moved accordingly for a quarter of a turn, and they've moved in the direction of opposite to a clock. Okay, so that's a couple tricks that we have used here. Okay, all right, so our first answer is E. Moving on now to question 2. Now for question 2, guys, it's a little balancing exercise. Right? It's making sure that when you have a scale, right, and the question wants you to balance both sides of a scale, it means what's on the left has to be exactly equal to what's on the right. Now you have different weights on the left and right. So it's best for you to see how much is on each side for now. Now you'll see from the diagram that the left is a little bit lower, meaning it's heavier. So if you add up the weights, you see it's 26 kilograms. And on the right, it's 19 kilograms. All right, so you just simplify the diagram, right? And then now you can move on. It says, which of the following methods would balance these scales? So we're seeing certain changes that will be applied, and it's meant to balance the scales, have both sides equal to each other. Right? So if you try number 1, if you add 5 and 7 to the right, right, means you're going to get 19, add 5 and 7, which gets you 31 kilograms. Now, if you compare that to the left now, 26, you'll see they are still not the same. It's not balanced. So therefore, anything with option 1 is completely out of the question, right? It cannot be our answer. If some of you smart cookies will be using process of elimination, cutting out the ones that have the wrong answers or the ones that won't work. So that means that you'll be cutting out option A, you'll be cutting out option D, and you'll be cutting out option E. All of them mention method 1. That's not going to work for us. So on to the next 2. If you add 9 to the left and 16 kilos to the right. So let's try that out now. So on the left, 26 plus 9 is 35. And on the right, 19 plus 16 is also 35. So we see the left and right are the same, so they're balanced. So anything with 2 is going to be correct. Therefore, C is automatically wrong because it doesn't mention method 2. All right, so that's why B is our answer. Okay, some of you guys might be going, that's trial and error, or that's guess and check. Yes, that's all you can do, because these kinds of questions that ask you which method works or which one's true, which one's false, right? And they give you these statements. You have no choice but to try them out, right? So in these kinds of questions, you got to do guess and check. You got to trial and error, see which ones work, see which ones don't. It's time consuming, but if you use those processes of elimination that I just used, cutting out all, as soon as you find one of the statements doesn't work, you cut out all the answers that have it since it doesn't work. Okay. Yep. So some of you guys had a question about the tails and end method back on question 1. So quickly go through that. Now, the tail and end method means you pick one part of a picture or a diagram and you call it the tail or the end, right? Actually, it's not tails and it's heads and tails. So sorry about that. But it's called heads and tails. And you basically call one part heads and call one of them tails. And you'll see what happens to the heads and what happens to the tails when you apply the transformation. So if you had to turn it, where does my head go? Where does my tail go? Where does it point? Right. If you reflect it, okay, so is my head reflecting? Does my tail have to reflect? Okay. We just call it heads and tails, but it doesn't always have to be top and bottom. It could be left and right. Just calling it heads and tails, just so you know what's what. Okay. So for example here, if this was heads and this was tails, right, you'll see that your head, since it's pointing up or north, if you do a quarter turn or a 90-degree turn in the opposite direction of a clock, which is from right to left, your head is now going to point to the left. Okay. Whereas your tail at the bottom, since it was pointing down or south, if you again move it from right to left, right? So so if it was pointing this way, this downwards, it's now going to shift and point to your right. Okay. So it's just a little name calling exercise. That way you know or how to follow which parts of your diagram are changing. Saves you having to picture the whole diagram moving, okay? Because you're only looking at certain parts like your heads and your tails. All right, so let's move on to question 3. Now for question 3, it's what I call a ratio question. It's comparing different quantities, different measurements, right? Now these measurements, they could be measuring different things. Here's an example. So on this question, it tells you that there's a map. The fact that they mentioned map is a big giveaway for you guys, and it will involve this topic. Now, on your map, you have the distances between 2 places on that map, right? But then they tell you that in real life, there's a bigger distance, right? Since on the picture, it's going to be smaller, but in real life, it's much, much, much larger. Okay. Now, they tell you, so we'll just write those down, the 2 things that are being compared, the distance you measure on the map versus the distance you measure in real life. Okay. Some of you might say, well, I don't use verses. I use a colon. Yeah, that's how it is in your normal maths questions. I'm just putting a verses just to simplify it. Now, they tell you, they give you a little legend here, little piece of information that helps you understand the conversion between what's on the map to what it is in real life. What's the measurement in real life? So 1 centimeter on the map is equal to 10 meters in real life. Okay. Now, the question where the question mark is, it asks us, what's the measurement in real life? So you put a little question mark there to show yourself that's what I'm finding. That's what I need to answer. Right. Now, there's 2 things that we have a problem with. 1, what's the measurement on the map, right? We need to work out the measurement on the map before changing it to the measurement in real life. Now, on this ruler, if you measure it, you'll see that the points that each place touches are 40 and 150. So you want to see the length between them is the difference between these measurements on the ruler. So the distance on the map is equal to 150 minus 40, which is 110. Now I want to stop right here. These questions always try to trick you, play mind games on you, right? They hide these little annoying pieces of information that can totally throw off your calculations. You might be doing all the steps right, but the numbers don't match up, right? Or your answer won't match up. And why is that? It's because every time you do a question with measurements, you need to always check the measurements. Wherever there's anything measured, you need to check the units. You'll see on the ruler, it was millimeters, but our answers are in meters, and our comparison is between centimeters and meters. So that means you need to change those millimeter units to centimeters. So the distance on the map wasn't 110 centimeters. It's actually 11 centimeters. Why is that? From millimeters to centimeters, right? You need to divide by 10. since there's 10 millimeters in every centimeter. So instead of 110 millimeters, you divide by 10, it's actually 11 centimeters. So now you can write down 11 centimeters, which is the distance on the map. And now you can try to work out what the distance in real life was. Every time you see these different comparisons or ratios, right, you go from one ratio to another ratio. What you'll find is that if you do a change to one side, you'll do the same change to the other side. So from 1 centimeter to 11, you have to times by 11. Same for the right. Whatever you do to one side, you have to do to the other. So your answer is actually 11 times 10, which is 110 meters in real life, which is A. Okay, how are we going so far, guys? All right. So takeaway from this question is if you see there's a question that has different measurements, right? Different quantities, different amounts. So you might have another question that has marbles being compared. Timothy has 5 marbles. Tracy has 20 marbles. So they could be comparing how many marbles. Here, right? It doesn't have to be marbles as well, right? It could be lollies, right? It could be how much rope. In this case, it's the distances, right? All right. Doesn't have to even be the same units. So you had marbles, you had lollies, but they're the same unit because you can count them. Sometimes you have questions where the measurements are different units, but the actual thing, which is distance, they have the same things being measured. Just how the measurements look, it can change depending on the units, exactly like this question. So be careful, right? Make sure all the units are placed correctly, right? So if you have a map versus real life distance, you're going to get two different, right? You're going to get two different things, okay? Two different units. So you got to make sure that if they have the same change occurring, which is timesing 11, the final answers have to also be in different units. Okay. All right. So that your answer here was going to be A. Okay. So for question 3, let's try that again. Okay. So if some of you guys, I'm not too sure where you're stuck on, but we'll just run through it one more time. With here, it's the topic called ratios, which is comparing different amounts. The amounts here that you are comparing are distances, right? But distances for two different things. You have a map distance, how much you're measuring on a map, versus the measurements in real life. Now, of course, what you measure on a map is less, and in real life, it's much more. Now, how you show those distances depends on the units. So as you see here on a map, you use small units like centimeters. So they say 1 centimeter on a map is actually compared to 10 meters in real life, okay? But because they can't measure 10 meters on a map, they have to shrink it down to something smaller, so it fits on a page, they measure it in centimeters, all right? So it's meant to help represent each other. On a map, it's actually 1 centimeter is representing 10 meters. On this question here, they want you to find how much the distance is between Nyla's house and Oscar's house, but in real life. So you're going to put a little question mark there because we're looking for a real life answer, right? Problem is we don't know what the distance is on the map between these two houses. So you got to measure that. So from 40, right? So from 40 over to 150, right? If you minus those two, you'll find that the map distance is 110, but we'll stop right there. This was measured with a ruler, and the ruler's units was millimeters. So that those millimeters have to turn back into the map's original units, which was centimeters. So from 110 millimeters into centimeters, we need to ask ourselves, what's the change? Since there's more millimeters in 1 centimeter, right, you need to divide, because when we're moving to a bigger unit, our number is going to get smaller since the bigger unit represents more of a distance. And 1 centimeter has 10 millimeters, so you divide by 10. So it's 11 centimeters. So now we know what we're actually comparing. We're comparing 11 centimeters on a map to how many meters in real life, right? Now we know that 1 on the map, 1 centimeter on the map was 10 meters in real life. So if we're jumping to 11, which is 11 times, right, the distance, the 1 centimeter on the map, that same change has to happen to the real life number as well. Has to grow, but in an equal way. If it's growing on the map, in one way, it has to grow the same way in real life as well. So you have to times by 11. So 10 times 11 is 110. That's why we get A. Okay. All right. So it's going to wrap up question 3. We'll move on to question 4 now. All right. If you didn't get to write the working out down, that's fine. Please check the recording after our webinar. Okay. So number 4, for this particular question, right, they want you to find what the black triangle represents. What number should belong there? But we can't find that out unless we fill in all the other missing spaces. And that just means we're using our order of operations, or we're just applying the operations. So we see that there's going to be two numbers in two boxes, and in between them is a symbol. And you just have to apply that symbol. So 14 plus 13 is 27. 27 minus 3 is 24, right? Then our next box times by 3 reaches 24. So you ask yourself, look at your times tables. What times is to 3 to get 24? It's 8. 8 times 6 is 48. So now we see that 48, we take away a number from it, and it should give us 10, right? But if you don't know what number should go there, that's okay. What you would do is you want to make sure that this triangle ends up by itself, right? You want it to be by itself, and you don't want any minus symbols in front of it. You want a plus symbol. So what you would do, guys, is you can plus a triangle to each side. So you see how the signs are different, a minus and a plus. So on the left, those triangles will cancel out, and you're left with 48. On the right, it's 10 plus the triangle, right? Now from here, right, again, you want the triangle by itself. So if there's no symbol in front of your number, it means it's a plus in front of it. If you want to get rid of it, you just minus that number from both sides. Keep it balanced. So you minus 10 from the right side, 10 minus 10 is 0. So of course, you're left with your triangle. But on the right, it'll be 48 minus 10, which gets you 38C. Okay, so that was a bit of an order of, it has operations for you to do, but the tricky part here was solving for your missing number. Whenever you have a missing number, you want to move it in a way so that it's by itself. Now, there is a faster way to do this if you don't want to go by the book. And what I like to do is I just imagine myself moving it to the other side, and the sign in front of it changes. So if I move it over, it just becomes a plus. And the 10, well, I don't want anything next to my missing symbol, my missing number. So I bring all the other numbers so that they belong on one side. So if it's plus 10 on that side, on the right, I bring it over, it's going to join up with the 48, but instead of plus, it's going to be minus, right? 48 minus 10. So that's a little bit of a shortcut way to our original steps. They still do the same thing, but you might find it easier to remember that way. Okay. Alrighty, let's move on to question 5. Now, question 5 is comparing fractions. Now, these can be really tricky. Now, the fact that they're mixed fractions already makes them a problem. So the first step is to go, right, we got to move them to improper fraction. Okay, improper fraction. That means, now how we change them to improper fraction is you take, I'm just going to write them out as a general formula or structure. So in your mixed fraction, you have a whole number on the left-hand side, you have your numerator at the top and your denominator at the bottom. Now, when you're changing an improper fraction, your goal is to get rid of that whole number. So by the end, you shouldn't have that number on the left-hand side. How we do that is we take the bottom number, you times that to the whole number on the side, and then you're going to add that to the numerator. Okay, so if we try A again, 4 times 1 is 4, plus 3 is 7. So the numerator changes, but not the denominator. That stays the same. For B, 2 times 1 is 2, plus 1 at the top is 3, and we keep the denominator the same. C, 3 times 2 is 6, plus 2 at the top is 8. D, it's 3 times 2, which is 6, plus 1 is 7 over 3. And finally, E, 2 times 2 is 4, plus 1 gives you 5 over 2. Notice how for each of these improper fractions, the bottom number stays the same. All right, so that's the improper fractions done. Where do we go from here? Well, you actually got to make sure that if you're ever going to compare fractions to anything, you got to make sure all the denominators are the same, right? If we're going to compare all of them to 2 and see which one's closest, each of these fractions has to have the same bottom number. So we're going to convert them so that they have the same bottom number. How do we get that exact same bottom number? Well, you look at every single denominator, which is 4, 3, and 2. They all have to times to a common number, which is 12. 4 times 3 is 12, times 3 is 12, 3 times 4 is 12, and 2 times 6 is 12. Notice how they can all reach 12. Right, 12 is a common multiple. So that's going to be your bottom number. And we've just written how much of a change we need to do for each of these numbers. So I'm just going to write them over here and explain them. So let's start with the top 4. To get to 12, you times by 3. Now 2, you times by 6 to get to 12. And 3, you times by 4 to get to 12. All right. Now, the rule is whatever you do to the bottom, you do to the top. So the top 7 also has to times by 3, right? So 7 also has to times by 3. 7 times 3 gets you 21. So same for the bottom. If you times for the B, if 2 times 6 is 12, you do the same to the top. So 3 also has to times by 6. And for C, 3 times 4 is 12. So the top number has to times by 4 too. 8 times 4. And we'll just repeat that for the bottom two. Whatever you times to the bottom, you do the same to the top. Now you just have to see what your new numerator is for all of these fractions that share the same bottom of 12. 21 over 12, 18 over 12, 32 over 12, 28 over 12, and 30 over 12. All right, so we're almost done. If we were comparing all of these fractions with each other to see who was biggest, who was smallest, we can do that now because all of them have the same bottom. You just have to see which one has the biggest number at the top or the smallest one. But that's not what the question wants. They want us to compare these fractions to 2. Now, 2 is a whole number, so you need to represent that as a fraction. If you're going to compare it to these fractions here, you need to change 2 to a fraction as well. Now, if you want to do that, 1, make sure the fraction of, if you're changing 2 to a fraction, the bottom or denominator is also 12. That way you can actually compare them with the fractions you've written up so far. Now, for 2, in terms of the numerator, it'd be the denominator times by what that whole number is. So 12 times 2 is 24, right? So that's how you represent it, right? And if you want to check, just divide the top number by the bottom number. And you see that it does get you 2, okay? And now if you compare each of them to 24 over 12, you're just comparing the top numbers. The bottom numbers are all the same. You just look at the top numbers. So it becomes 21 versus 24, 18 versus 24, 32 versus 24, 28 versus 24, and 30 versus 24. Which option had the smallest jump to get to 24? Now, 21 in A, 21 over 12, it only had to move by 3 to get to 24 over 12. That's why A is your answer. That's the closest, the smallest jump. Okay. Another way you could have done this is you could have tried to draw a diagram, right? But then every single one of your diagrams had to be exactly the same as each other, the same bar length, right? So you could have done it that way, right? Since you have 2 bars, right? So that means you would have had to shade them, each of these, into that block and compare them to see which one is closest to filling up these entire 2 blocks. You could have done that as well, right? So here's an example. If you had done A, 1 3/4, you shade in 1 block, and then you break up the third one into 4 blocks and shade in 3. So if you had things like C, you add 2, and then you do a third, right? So you can shade in 2, and you can see how much. So you can add up by 3. You draw 3 bars, and then you just repeat that for B, D, and you could do that as well, right? If I were to do the diagram method, I feel like it would take a lot longer, and there are more errors that can occur just because when you draw a diagram, sometimes they may not be perfect or lined up perfectly with one another, right? So that's why doing the fraction conversion method is a little bit more accurate because everything's all numbers and all of them share the same denominators, right? And so therefore you're just comparing the numerators. So that's a diagram method, okay? But the answer is A. All right, so on to question 6. What number do you get if you add 11 thousands, 11 hundreds, 11 tens, and 11 ones? Just got to see what numbers you're adding. So 11 thousands is 11,000. Add that to 11 hundreds. So put 2 zeros at the end. 11 tens, so put an extra 0 at the end of 11. And 11 ones, which is just 11. So you add that all up, guys, and you should get 12,221. Okay. If you're going to add, just make sure you use an algorithm. Don't do it in your head, guys. You're going to get tired. You're going to make more silly mistakes. No point, right? So 11,000, when you do add in an algorithm, just make sure it's all lined up in the right positions, okay? Just add downwards, right? It's all ones and zeros, so no having to carry over it or anything. So that was D. 7, this question involves rounding. Now, they mentioned Tristan has $20 and he's buying a couple things, right? And for each of them, instead of adding them accurately, Tristan's going to round up or down these numbers to the nearest dollar. Nearest dollar in this case, guys, is the nearest ones or units, right? So if you're going to be rounding that spot, what you're checking is one spot to the right. If it's bigger or equal to 5, right? So when you're rounding a position, you're checking if the spot on the right is bigger or equal to 5 or less than 5. Which one is it? Right? If it's bigger or equal to 5, then yep, you round up. But if it's less than 5, you keep the digit the same. Or you round down. Okay. So let's give that a shot. 645, you're rounding the dollar, which is 6, the units. Now you check to the right, so you have 4, which you're checking. So 4 is less than 5. So our problem here is that 6 is going to stay the same, and since you're rounding down, everything becomes 0. $6. $2.35, same problem. 3 is less than 5. So that 2 that you're rounding, the units, it stays the same, and everything else becomes 0 to its right. Now, 885, here's a superstar. Number 8, right? Not the one next to the dollar sign. That's the position that you're rounding. So you're going to check the spot to its right. And you see that 8, it is bigger than 5. So what happens to the spot that we're rounding and the number on it? That 8 is going to become 1 higher, which is 9. And everything else becomes 0. Okay. Now the question wanted to see how much change you'll get if you rounded all of these tags and then added it up. If we're talking about change, it means you're subtracting the costs from how much money you have. So the change is equal to how much money you have, 20, minus how much you're spending. Okay, so it's 20 minus 6 plus 2 is 8. 8 plus 9 is 17. So 20 minus 17, which gets you $3, which is D. Okay, all right, moving on. Question 8. Now, for this question, it might look super scary if you just look at the diagrams. But if you read the questions, then it becomes simpler. So Andrea tells me that, the question tells me Andrea has 2 objects, each with an identical number of cubes. So at some stage, you're going to have to figure out how many cubes there are in each block. Okay. Then she tells me that she's going to break them up into tiny cubes, right? And wants to know how many of those objects below can she make with the amount of cubes that she has. So what they want you to do is take all of these blocks, or these 2 blocks, and each of them, they have tiny little cubes. They want you to find out the total cubes. Right? And from these total cubes, you're going to take a couple of them to make your shape below, which needs how many? It needs 1, 2, 3. But this shape that's sitting at the top, it is sitting on a hidden block behind it. Okay. So it's 3 plus an extra hidden one, which is 4 cubes. All right. So that means if we're finding the total number of shapes or objects, then you're going to get the total cubes divided by the 4 cubes, since it takes 4 cubes to make one of your shapes. All right. How do we get the total number of cubes? Well, you look at each of these blocks of cubes, and you just have to multiply the dimensions. Kind of like the area, right? It's kind of like area to see how much of this space is filled up by blocks. Okay, so we see that there's 1, 2, 3, 4, 5. There's 5, right? 5 columns, and each column there's going to be 1, 2, 3, 4. 5 columns of 4. So 5 times 4, that gets you 20. Okay, but there's not just one block. There's 2 blocks. There's another 20 cubes. So altogether, you have 40 cubes divided by 4, which gets you 10. Just C. Okay. All right, on to 9. Maisie is building a wall using bricks, 1 layer at a time. She always completes 1 layer before starting the next layer. Each layer is made from 6 bricks. Maisie has 26 bricks and she uses them all. Which layer is she working on when she lays her last brick? Now, you see the word each. Again, you think of timesing and dividing. So she's dividing up these 26 bricks into layers. And each layer has to have 6 bricks. All right. So you have 6 in 1 layer, then you have another 6, and so on. And then they want to see how many layers can I get, right, if I have 26 bricks. So that means we're going to divide 26 by 6, since each layer needs 6, and we'll get how many layers from there. 26 divided by 6 is 4, remainder 2. So you get 4 complete layers, right, and 2 remaining, right? Now the question asks, which layer is she working on? We've done 4 complete ones. So the remaining 2 means she's already on her 5th layer, B. Okay, so that question might look scary, but once you apply the rules, right? Apply the rules, draw some diagrams to present your information in a different way, it's a lot less scary. All right, on to question 10. Oliver has a box of 16 colored discs. You got all those numbers of discs for each color. He picks 1 disc at random from the box. I'm going to underline that and come back to that. Which of these statements are correct? Statements. So from our very first question, or our second question, we know we're going to do at some stage trial and error. I remember how I said just because you read or see a diagram or you read a couple words doesn't mean it's going to be exactly just that topic. We saw statements, so we know it's trial and error, but picks, when you're picking things, you have a chance of getting what you want or what you don't want. So it's chance and probability. That's the topic also involved. Now, what's our rule for chance? We'll call it chance since it's an easier word than probability. Our rule is if you want to find the chance of a outcome or an outcome, so whether you want green, blue, not blue, or green and red, for example, those are the outcomes. So how do we work them out? Well, in a fraction bar, you're going to put as the numerator the total possible outcomes. So if you had to pick one color, how many discs are in that color over the total selections? So the bottom number is how many things are there to pick out, right? If you stick your hand in that bag or you stick your hand in that box, how many things are there that your hand can touch, right? If you counted it one by one, how many things are there for you to pick from, right? But the top number is the number of ones that you want, right? Not you can get, but you want, okay? So simply, right, we already know how many selections there are. There's 16 of them, 16 possible things to pick. But in terms of what you want, that's going to be given to you in these statements. So you just check. Blue, it is certain that he picks a blue. Now, certain means you're for sure going to get a blue. Not there's a high chance, but if in any situation you're going to get a blue, meaning everything has to be blue, which is not true. So automatically, anything with one is wrong. Nope, nope, and nope. B, C, and E are wrong, right? Now, on to checking the remaining two. It is equally likely that he picks a blue disc or does not pick a blue, right? Meaning that if your chance of getting blue has to be half, equal yeses and equal nos. So now you get to figure out how many blue options are there to pick from. Possible blues, there's 8. So 8 over 16, you simplify that, that's half. So that's what we mean by equally likely, 50%. Right? So anything with 2 is correct. So D is right. Since we know 2 works, A is also wrong. Okay, so I'm hoping you guys are seeing a pattern here. As soon as you find out a particular option, you can start kicking out quite a few others that don't work. Okay, all right, so moving on to question 11. Omid has a 1 liter measuring jug. It contains 100 milliliters of water. He has some identical blocks. He drops 2 blocks into the water and they sink. The water level rises. Omid drops 5 more blocks into the water. What is the new water level? If I find that sometimes it helps to draw a diagram here. So it's currently at 100 milliliters. You chuck in 1 block and all of a sudden it's at 150 milliliters, right? So that means that by adding 1 block, you've gone up by 50 milliliters. Oh, sorry, it wasn't 1 block, it was 2 blocks. So 2 blocks. And that gets you up to 50 milliliters. Now the question says you've dropped 5 more. What's the new water level, right? So since you know 2 adds 50, you need to see altogether there's 7 blocks. So you need to see what's the change if you add 7 blocks. So what happens if we add 1, 2, 3, 4, 5, 6, 7. 7 blocks, okay? This is going to involve more rates and ratios, comparing measurements. On the one side, you've got blocks, 2 blocks. On the right side, it's the level change. So 2 gets you to 50 mils, to plus 50 mils, and your goal is 2 plus 5, which is 7 blocks. What's the change there? Right, if you guys enjoy fractions, you could see the change straight away. From 2 to 7, you times by 3.5. Right? But so if you guys don't like dealing with fractions, that's cool. You use something called unitary method. You bring these units down for the blocks, right, or for the levels, the mils, to the lowest they can go. Here's an example. Well, what's the simplest number for the unit for the blocks? Not 2. You can go a little bit lower. What's 1 block worth? How much change happens if it's 1 block? So to get from 2 to 1, you got to half it. And whatever you do to one side, keep it balanced and do it to the other. So 1 block will bring a change of 50 divided by 2, which is 25. So your water goes up a little bit, 25 mils. Now, from 1 to 7, 7 is the change we want. So from 1 to 7, that's just times by 7. And again, what you do to one side, you do to the other. So it's 25 mils that you would have added for 1 block, but it's times by 7 now. So your water is going to go up way higher. Now use an algorithm. 25 times 7. So 5 times 7 is 35. Carry the 3 up. 7 times 2 is 14. Plus 3 is 17. Okay. So it's 175 meals that you're adding. Okay. So you're adding 175 meals to your original 110. 100. So your final or your new level is you're starting 100 plus that extra 175 from all of those blocks, all 7 blocks. I think it's not sure what you guys can see right now, but one of these has to be a 7. And you should get 275 milliliters B. Okay, sound good? All right. So what did we find really helped us out here? One, if you had noticing that different measurements are being compared, you got the number of blocks and milliliters, right? If one causes the other, you definitely think about rates and ratios. When one thing changes, another thing changes in the same way. Some blocks change, you have water level changing. Okay, so I like to put a versus to show that they are, both of them are changing at the same time. Okay, moving on to 12. Now on to 12, you have a graph, right? And the question says, how many more drinks do you need to sell to reach a target? Now, if you read that by itself, no way you're going to know where to go. You don't have any clues. You don't know what the graph's showing. So you have to just go back up. A restaurant has a target to sell 150 drinks each day. So if you add up all of these, you need to get to 150. All right. They say each graph shows how many drinks they've sold so far today. Now, you just got to read the graph, see where this bar graph touches. So T, it lines up with this notch there. It's not exactly halfway, right? But it's somewhere between 0 and 10. Let's have a look at the others. So for coffee, it lines up with 20. For juice, it lines up with 30. And for water, it lines up with 50. Okay. So now we just have to go back and work out how many tea drinks were bought. Now, from 0 to 10, you'll see that there's how many gaps that are moved. There's 5 gaps. So each of these spaces, I call them a gap. So there's 5 of them, right? So every time you move to a different notch, you're jumping over a gap. So 10 divided by 5 means it's 2 drinks for every gap. Okay. So where does that leave us then? So it has moved to 3 notches or 3 gaps. So it's on the 4th notch. So it's 3 gaps times by 3. It's 6 drinks. So there's 6 teas that were bought. Now you can add them all up and see where you're at. 6 plus 20 plus 30 plus 50 is, add them all up, equals 106 drinks. So now you ask yourself, well, how many drinks are left? 150 minus 106 is 44 drinks remaining. Okay. So a couple things involved here. One, the question is not all about the graph. I know, it sounds weird, right? The question's actually more of breaking down what you need to find, right? And what is left, right? So you needed to make a number sentence first, which is total you need minus what you got. And to get the amount that you have so far, you needed to read the graph. So that's when the graph comes in. But if you didn't know or have that number sentence of this total is equal to all of these added together, then you wouldn't have known what to find, what to add, etc. Okay, so that's 12. 12 is A. 13, Sean starts with the number 53 and follows these instructions 5 times. If the number you have is odd, add 1, or if it's even, divide by 2. After following the instructions 5 times, what number does Sean have? 53 is your starter. Right? You start with 53. Now let's apply the instructions now for the first time. 53 is odd, so you plus 1 gets you 54. All right, that's your first. You've used the instruction once now. Let's start again. 54 is even, so you need to divide by 2, getting you 27. That's the second time you've used the instructions. Now we start again. 27 is even, odd. You use the rules and you add 1. So it's odd, getting you 28. So third use, 2 more uses. 28 is even, so you divide it by 2, getting you 14. That's the 4th. Now, a lot of students here, they're in the flow. You're doing all these calculations. It's easy just to continue on like a habit. Odd, even, odd, even, odd, even. But you need to pay attention. The number you just finished off with is 14, which is even, not odd. So what you would need to do is divide once more to get you 7, right, which is B. Okay. A lot of students would have gone, okay, plus 1, because it's odd, even, plus divide, plus divide, plus divide. All right, but you need to be careful and see what the new data is, okay? What the new change has left you, and consider the rules once more. So if there's any questions with patterns or rules, if you're applying it multiple times and there's different conditions or different rules, depending on the numbers you get, you need to pay attention so you don't accidentally make a silly mistake. 14. What is the area of shape Q? Now, for some of you guys, you would have learned about your area formulas. So you see there's two rectangles here. So area is length times width. So you can measure what the lengths and widths are. Now, if you do that method of the area formula, you have to be careful because you need to make sure that each time you go from dot to dot, it's actually worth 1. A lot of students make the mistake of assuming it's moving 1 centimeter or 1 unit. Sometimes the question tells you it's worth 2, 3, 5, 50 units, and you'll make a silly mistake. So you need to be careful there, all right? Now, if you measure it, you see that this rectangle is worth 2 by 1. So if your area for your rectangle is length times width, 2 times 1 is indeed 2 centimeters squared, just like what the information told you. So each dot to dot is in fact worth 1. So you're lucky. We're lucky this time. Okay. So now if we apply our formula once again for our shape Q, you need to know what the lengths and widths are. So just measure it. 1, 2, 3, 4, 5. For your width, 1, 2, 3. So it's 5 times 3, getting you 15 centimeters squared. If you're not a fan of calculations, guys, no stress. You can do the traditional shading in method. Now, once you've worked out that the dimensions are actually 1 centimeter from dot to dot, then that means every square is worth 1 centimeter squared. So you just shade it in. That's 2. So for your shape cube, you divide up your shape into squares and just count them. So you'll see if you count it all, it's 5 rows of 3, getting you 15. Okay. All right. So yeah, either way you get C. So there's 2 methods. You got the counting method or you got the area formula method. Whichever tickles your fancy. On to 15. 4 bananas weigh the same as 6 apples, right? Now, for this question here, there's combinations. And whenever you're comparing combinations, I like to change the total so that it's all in one unit or one kind of units. So here's, for example, all worth apples, or all worth bananas, right? Now, if you want to do that, you need to see how they relate to each other. How do bananas relate to apples, all right? They tell you that 4 nanas is equal to 6 apples. You can go ahead and simplify that. 2 bananas, if you half both sides, you'll find that 2 bananas is worth 3 apples, okay? So now, knowing this, I can go into each of my combinations in each bag, and I can work out I can change all the bananas to all apples or all apples to bananas. All right. Now they tell you that in bag 1, there's 9 apples. So what I'm going to do is I'm going to change apples to bananas, right? Now 9 isn't exactly our starting 3, but from all those other questions we've been doing, we know that if we do one change to one side, we do to another. So 3 apples to get to 9, right? So since you know that 2 bananas is equal to 3 apples, to get to 9 apples, you need to times by 3, and then you do to the same to the other side. So it's 6 bananas, right? So you can go ahead and get rid of 9 apples and make it all in terms of bananas. So 6 nanas. Do the same for bag 2, 6 bananas and 12 apples. Let's change that. So from 3 apples to 12 apples. So I'm just going to write 2B, 3A, B for banana, A for apple. Saves time. You're going to 12 now. So it's times by 4. Do the same to the bananas. That's actually 2 times 4, which is 8 bananas. So instead of 12 apples, I know that 12 apples is worth 8 bananas. So you see how everything's in terms of bananas, right? So I'm guessing monkeys would really like, if a monkey was doing this question, they'd really like it because everything's in terms of bananas. So bag 3, 3 apples. Oh, no need to change anything since we already know that 3 apples is worth 2 bananas, right? So what we can do is since everything's in bananas in each bag, you can add them all up to see what's the total number of bananas. Bag 1, 10 plus 6 is 16. Bag 2, 6 plus 8 is 14. Bag 3, 16 plus 2 is 18. Now, what have we seen? All of them have different results. All of them have different bananas. So they have different weights then. There, so E is our answer. Okay, so that's how you deal with these questions with combinations. You got to make sure all these combos are in terms of one missing thing, one thing you don't know. So if we don't know the weight of the banana, we don't know the weight of the apple, like the exact weight, right? I don't want to cause myself a headache. I might as well just turn everything into the same unit, bananas or apples, not both. And you can only do that once they give you a clue comparing how much is worth the other. How many bananas are worth apples? That way you can easily switch, right, and convert them and switch. All right, so that's E for 15. On to 16. Which of these are correct? So this question is purely, right, you gotta, for this question, if you didn't do geometry in class at school, be tough, right? Or if you've been to Alpha One, it would have gone through this topic. But the bottom line is you encounter questions that are purely just related to the rules and the normal general theory for these topics you learn in class at school. They don't require any problem solving. And for this question, just checking which statements are correct. So number 1, all rhombuses are parallelograms. Now that's correct, right? Parallelograms are two pairs of equal sides, right? And opposite angles are equal to each other. For a rhombus, that's technically correct because while all four sides are equal to each other, if you match up two of them here, they will match up to these, okay? Just even considering how they appear, right? They look very similar. So one is a giveaway, right? So you got these opposite angles being equal. Yep. And you got two pairs. Actually, whoops. Let me just change that. That is not right. So if I draw my parallelogram again, you have these two sides being equal, and you have these two sides being equal. In terms of angles, those two are equal, and these two are equal, okay? But overall, the general shape should give it away. So anything with statement 1 is correct. So get rid of B and C, right? And here's the trick, guys, right? Right, now, if you guys were to go, okay, since B and C don't work, or 2 and 3 don't work, that means that I get rid of D and E because they have 3 and 2 in them. Not quite, guys. That's because we want an answer with 1 in it, right? Well, you get rid of E for sure. But just because you can get rid of them doesn't mean that the actual statements are false. The reason why they're wrong is just because they don't have 1 in it. Now, if we check 2, all rectangles are kites, guys, that's not true. Problem with our kites and our rectangles, right, is that in our kites, the diagonals meet at 90 degrees. But if we look at our diagonals here, they don't necessarily meet up at 90 degrees. So therefore, that breaks down one of our statements. But the fact that in terms of the opposite sides, right, because rectangles, you have opposite sides being equal to each other. Kites, that's not the case. So anything with statement 2 is wrong. So therefore, E is wrong and B are wrong. And 3, all quadrilaterals are squares. That's not the case. Remember, quadrilaterals are shapes with 4 sides. What if I have a trapezium? Does that look like a square to you guys? Not really, right? It's that all squares are quadrilaterals because all of them have 4 sides, but not the other way around. Because squares is more specific. Quadrilaterals are very broad. Okay. So if it was the other way around, it'd be right. But since it's not, 3 is also wrong. So only 1 is correct. A is your answer. All right, on to question 17. Now, this one is one of the more difficult questions. It says you're making a fence around square pieces of land. Each fence has posts. So these are the posts, the vertical bits, and the gaps between them are 2 meters. There's a post at each corner of the square. To make a square with side length 4 meters, she needs 8 posts as shown in the picture. So if you count all the posts, you'll see that they needed, right, 1, 2, 3, 4, 5, 6, 7, 8. They needed 8, right? 8 posts, right? But the side length is equal to 2 meters, right? Side length is equal to 2 meters, and that matches 3 posts to cover the 2 meters, right? 3 posts. So in other words, 2 gaps, right? 2 gaps, okay? So since they wanted each side length to be 4. So now where can we go with this, right? Where can we go with this? They want to make a square with side length of 10. So let's figure out how many posts we need on one side. So remember, the side length is equal to 2 meters that make up 1 gap, right? Times by a number of gaps. So if we want 10 meters, that means you need to times 2 by a number of gaps. And that number is going to be 5 gaps. But from our clues earlier, we saw that while the side length was 4 meters, you needed 3 posts, right? So the side length was 4 meters, so you needed 3 posts, right? And 2 gaps. So you'll see that between posts and gaps, there's always going to be 1 extra post than a gap. So the number of posts you need is the gap plus 1, getting you 6. So each side, it should be 6 posts, right? Not exactly. If you count it from one corner to the other, you're going to get 6. But here lies a problem. Now, from our original diagram, if I were to, since we saw that we needed 3 posts, if I were to put 3 on each side and add it up, that's 12. But how come when we count it up, there's only 8? It's because there's overlaps, right? Every time you count one side, it's 3 posts. But you're going to use those corner posts again to count the next side. So there's always going to be an extra 4 since there's 4 corners. So therefore, your answer is 24 posts minus the 4 overlaps. Every time you count the number on each side, those 2 corner posts those corner posts are going to overlap with the other side. So you need to take away the 4 posts, the 4 overlaps. Getting you how many folks? 20, okay? Which is option B, okay? So a lot of times, guys, if you deal with a post question, and it's around a perimeter or forms a square or a rectangle, right? Or pretty much any quadrilateral shape, you're going to have this problem, or any closed shape, you're going to have this problem of overlapping corners. So you just need to take away the number of posts that matches the number of corners, okay? Right. So let's move on. So for question 18, guys, they ask what's the difference between the temperature outside and the temperature inside. So you just got to read where the notches touch. Okay. All right. So for the left and the right, all right, we see on the left, it is touching at a notch somewhere between, or not quite at halfway between 5 and 10, but it's close. For our second thermometer, we see that it's quite close to 25 and it's touching what we could see is a bigger dash. Okay. Now in terms of where they touch, you got to be aware of what the notches are worth. Now, if we zoom in really, really small, let's see if I can zoom in here. You'll see that there are 2 kinds of notches, a bigger one and a smaller one. So you got to see what the bigger ones are worth. You'll see that there's how many of these? There's 1, 2, 3, 4 until you reach 10. That means they are all worth, the jump is worth 1, all right? And we see that where the temperature touches, it's between 6 and 7, the mini notch. So it's halfway there, so it's worth 6.5. Okay. So if we apply that to the other shape, if we look a little bit closer as well, that big notch, right? We know it was from each of those bigger notches to each other, it was by 1. So here it should be 24, since 1 more and it reaches 25. Okay. So when you're minusing 24 and 6.5, which is what the question wanted, a difference, 24 minus 6.5, you're minusing a mixed fraction from the whole number. So what you need to do is change that whole number to a mixed fraction. What you do is you sacrifice 1, so you leave as 23, and that 1 you sacrificed turns into a fraction. And what fraction is that exactly? It is a fraction where it's the other fraction's denominator over itself. Since in this case, 2 divided by 2 is 1. So if you got that 1 and added it, you would have gotten 24. All right. So that's the reasoning behind this sacrificing the 1 and turning to a fraction. Now, when you decide to minus, you can minus the whole numbers together from each other, which is 23 minus 6. And then you got the fractions, 2 over 2 minus 1 over 2. So this you can minus them since the bottoms are the same, just minus the tops. So you'll get 1 over 2. So it's 17.5, which is your answer. Okay. But when we reach 20, we'll take a break and we'll for 5 minutes and we'll come back and deal with the questions again. Now for 19, this one was, I'd say, quite straightforward. It looks scary. You might think there's measurements involved since it mentions tallest. But what the question wants you to do is stack them on top of each other and try to get the tallest height possible. Meaning, when you stack these, you just want the length that's the longest in the dimensions for each of them to be the height. Imagine I have this tissue box here. If I hold it in I'm turning it a certain number of ways, but you'll see that if I have it lying flat, it's not that high, right? But if I turn it and rotate it so that the length is standing up, you see it gets much taller. Same deal with these blocks. You can move them so that they're standing, right? And the longest length is actually the height. So if the first one was standing so that the height was 5, all right. And then for our next block, the height's also 5, right? So you can have 5 again. And then for our third block, 7 is the longest. So when you stack it, you want it in a way so that 7's standing. So 7 plus 5 plus 5 is 17. That's the max you can go. Okay, so it's D. And for 20, now for 20, this was also comparing portions or fractions. Now I say portions because it's how much is shaded out of the total. But when you think of portions, we think of fractions. Right? Now, they want us to see how many more squares we shade on the left shape so that it matches the same portion as the right shape. So you got to see what the fractions shaded are for each. So on the left, it's a grid and it's a square. So the lengths is that you have 1, 2, 3, 4, 5, 6, 7, 8. 8 squares by 8 squares, right? So that's 64 in total. So that would be our denominator. Out of 64 squares, how many are shaded? 1, 2, 3, 4, 5, 6, 7, 8. 8 over 64. On the right, it's all broken up into triangles. Now you want to see how many triangles there are in total. So 1, 2, 3, 4, 5, 6, 7, 8. And how many are shaded? 3. Okay. Now what we can see is that we have two separate fractions that we need to compare, right? But they have different denominators, so you can't compare them yet. So you need to make sure both of them share the same denominator. You could change the left one, so that's out of 8, or you can change the one on the right, so it's out of 64. Since our goal is to see how many we need extra within the 64, right? So our shape on the left, right? They're seeing how many extra we need so that it matches the right. That means the fraction that we're going to add has to be out of 64, right? So it's better to change the 3 out of 8, so it's over 64. So whatever you do to change the bottom, you do the same to the top. So times by 8 at the bottom, do the same to the top, you get 24. So now we can see we're going from 8 to 24. How many extra do we need? Well, just subtract them. 24 minus 8 is an extra 16 squares. Answer is C. Okay. All right, guys. So as promised, we're going to take a quick break now. So we'll come back in, let's say we'll come back at 6:35. 6:35. We'll come back and we will deal with questions 21 to 35. Okay. Sure. Do we just use the highest number of each shape? I believe this was for question 19. Yes, you use the biggest length, right? You stack it in a way so that the biggest length is the height. Okay. It's like a tissue box, right? You have the tissue box here, and then you just turn it so that the longest length is standing upwards. Okay, so that's how we just added up all the big numbers, the biggest numbers. Okay. All right, guys, I'll see you guys back at 6:35. Okay, and then we'll continue on from there. Okay, all righty. Okay, welcome back, everyone. So it's 6:35. So what we'll do moving on ahead is we'll go through all of these questions that are remaining. So from 21 onwards to 35, we'll deal with all of them. And if there's any inquiries that you guys have, or if there's any questions you're not too sure of, or any comments that you want to be addressed, then we'll address those at the end once we finished question 35. Okay, so we'll spend the next portion of time dealing with all these questions, and if there's any time remaining, we'll go through those extra questions you need me to address. Okay, all righty, so let's move on to question 21. I'm sorry, guys, please give me a moment. Not too sure why I can't get rid. Okay, there you go. Let's move on to 21. So in this question here, there's two ways you can go about this. So what they wanted you to do was you could take these shapes, A, B, C, D, and E, pick 4 of them and place them onto the grid, the empty grid below. And one of them won't be used, and that's going to be your answer. Now, you can certainly try that out, guys, but there was an extra approach that you could take here. Now, if you're going to get them to fill up the shape, of course, you need 4 shapes that when you add up all the squares should make up the total squares in the 6x6 grid. Now, how many squares you need altogether? Well, that's a matter of area, since once you add up all of these squares in the grid, it's the same as area. So since it's measured 6x6, to get the squares, you just need to multiply. 6 rows of 6 or 6 columns of 6 gets you 36 squares. So then you need to look for the shapes. When you count the squares and add the 4 values, gets you 36. The one that isn't used is the odd one out. Okay, or your answer, aka your answer. So now you just need to count how many squares are in each of the shapes above. So for A, it's 3 rows of 6. So 3 times 6 is 18. For shape B, it's 3 by 4. So 3 rows of 4, giving you 12. C, it's 3 by 3. So 3 by 3 is 9. D is 2 rows of 3. So 2 times 3 is 6. And the last one's just 3, right? So you pick 4 numbers that when you add them together should get 36. And you'll see that for A, if you got 18, and then you add C, which had 9, then you add D, which had 6, and you add E, which had 3, you will get 36. So therefore, B wasn't used, so B is your answer. Now, there was, you could have trialed and errored, right? You could have trialed and errored. That's the other way. So if you didn't want the straightforward way, the method of just adding it up and see which one isn't needed, you could have just trialed and errored and you would have reached that same conclusion. So if which shape is not used, A, you just need to add up B, C, D, E. Or if B wasn't used, you add A, C, D, E, etc. Right? So if you couldn't think of that, then once you started trial and erroring, you'll reach that point anyway, right? But needless to say, if you had decided to try piece them together one by one and shade them in, it would have taken a lot of time. So when it comes to filling in grids, simply adding up the squares would help you out. So 21 is going to be B, that's not used. 22, now you have 6 cards and each card should have a number on it. And when you add them all together, you should get 25. So you have 8 plus 4 plus 5 plus 2 plus diamond plus hexagon. And that should get you 25. So what you could do now is you could add up all the numbers they have given you so far, which is 8, 4, 5, and 2. That should get you 19. So notice how we've made a number sentence along the way. That's the best approach. Whenever there's combinations, make your number sentence. If there's missing numbers, make your number sentences. If there's any topic that involves calculations, even measurements, then you're going to need number sentences. So if you don't know where to start with finding a number sentence. Right? It can have different operations like divide, times, plus, minus, but you just try to reach a number sentence first, right? Now you've got your number sentence here, right? But you can still simplify it further. Why is that? We want all the missing shapes on one side and all the numbers on the other side. So right now 19 is not where it should be. So you want to get rid of it. Now, if there's no sign next to it or in front on its left, it means it's a plus. So to get rid of it, you minus 19. And if you do that, you do it to the other side to keep it balanced. So therefore, your two shapes, right, they are alone once the 19s cancel out. And on the right, 25 minus 19 is 6. So these two shapes add up to 6. But the question wants us to find what's the biggest possible difference. You might be going, well, where do I go from here? Right, I got plus, but how is there any way for me to get the subtraction? Well, this is when a bit of trial and error comes in. It's because there's only so many combinations you can have between these numbers so that they add to 6. So meaning 1 and 5 make 6, 2 and 4 make 6, right? 3 and 3 make 6, right? So those are your combinations. You just need to find the one that has the biggest difference when you minus the numbers in those pairs. So 5 and 1, they have the biggest gap. So it's going to be your answer. 5 minus 1 is 4D. Okay, it's a bit of trial and error involved, but we couldn't have reached that point without our trusty number sentence. The fact that knowing that they both add to 6 helps us figure out what the pairs of numbers could be. On to question 23. You have your thermometer here. Well, not thermometer, sorry. You have a container and it has measurements or notches to show its measurements. Now, a lot of students would make the mistake of assuming each big dash was worth 10. But if you had tried that, you'll notice that it wouldn't work. Right? Since there's an extra gap, right, until you reach 40, that should be 30, but that's not the case. So therefore, you need to work out what each of these notches are worth, what the value should be, all right? So we see there's 1, 2, 3, 4, 5. So 40 mils is worth 5 notches, all right? 2, 3. So it's like 5 jumps. Each notch is a jump. So therefore, one notch or one jump is worth 8 mils. So it's 8, 16, 24. All right. And from here, guys, you would ask yourself, okay, well, it's slightly higher than the bar that said 24. So my answer should either be A, B, or C. Those are the lowest ones. But to be extra sure, you need to know what each mini notch is worth. Now, we know that in our big jump, it's worth 8 mils. But how many mini notches are there? There's 4 mini notches that make 8 mils. So one mini notch or one mini dash should be 8 divided by 4 is 2. Now, therefore, guys, from 24 to our next mini notch, it's going to be 24 plus 2, which is 26 mils. So if you picked B, unfortunately, it would have been wrong. C would have been your answer. Okay. We know it definitely couldn't have been A. So it's really between B, C, maybe D, but B and C were the closest. Okay. So C is your answer. Just making sure that you don't assume what values measurement should be. You've got to work them out, especially if they don't give it to you. All right, 24, guys. This one is a working backwards question. So it tells you the answer you reach, but it doesn't tell you the starting number. So when you work backwards, you use the steps, but in the reverse order. So what was your last step becomes your first step that you used. What your final number was is your new starting number. Now, also, when you're working backwards, the actual operations, you do the opposite. So if instead of multiply, you divide. Instead of plus, you minus, etc. All right, so working backwards, we start with 40, and now what was our last step before is now our first step, except we do the opposite. So instead of multiplying by 2, we do the opposite, which is divide by 2, which gets us 20. Instead of adding 4, we're going to minus 4, which gets us 16. Then they ask, what do you get if you add together the digits? So 1 and 6, you add them, you get 7, which is B. Okay. So that is working backwards, making sure what was your last step becomes your new first step, and what the operations were in each of the steps before are now reversed when you work backwards, or not reversed, they are now opposite. Okay, so on to question 25. The children in the class are making up a new type of money. They decide that 9 squigs are worth 2 zots, 3 zots are worth 5 grozels. How many squigs are 20 grozels worth? So for these questions, when you're comparing values again, it makes us think about our ratios, right? It makes us remember that every time we compare, right, we didn't make sure that if we're changing one of the values, the other side has to experience the same change. 9 squigs, we'll call it 9s, is worth 2 zots or 2z. Then they say that 3 z's are worth 5 grozels. Now, for these types of questions, when you're comparing more than one quantity, right, and then you'll see that there's always a common quantity. And what do we do there with these common quantities? In this case, both of these comparisons mention zots in them. Well, if you're going to compare the extra or the other quantities, right, you need to make sure that all the comparisons contain the exact same quantity. There's a quantity that's exactly the same units, so zots, but the number in front has to be exactly the same as well. Otherwise, you cannot compare them. So yes, they're both zots, but you need the numbers in front to be exactly the same. So 2 and 3. How do you get them the same? Well, we think about common multiples. How much can I change 3 zots and 2 zots by until they're the same? Well, when you're not sure of what the multiples can be, just times the 2 numbers. So 2 times 3 is 6. So you need to go from 2 to 6 or 3 to 6. So for 2, if you times by 3, you get 6. For 3 zots, you times by 2 to get 6 zots. Okay. Now, if you do decide to do that, if you do decide to do those changes, in those comparisons, you need to do the exact same change to the other side. So if you times 2 zots by 3, you need to times the 9 squigs by 3 as well, giving you 27. Now, down below, you times the 3 zots by 2. You need to do the same to the grozels. So 5 times 2 is 10. Okay. So now you have a new comparison. 27 squigs are worth 10 grozels, but we're not done yet. The question wants what 20 grozels are worth. So to get to 20 grozels, you need to times 10 by 2. And whatever you do to one side, you do to the other. So 27 times 2 is 54. Okay. So that's how we deal with these kinds of questions. When you have different quantities being compared, right, and they have these comparisons where you have 2 items each, there's always going to be a common one. And what you want to do is make those common ones exactly the same in units, so in this case zots, and exactly the same in number. And once you do that, you've changed the number. So what you did there, you have to do to the other side of your comparison. So changing the squigs exactly the way you changed the 2 zots. Changing the grozels the exact same way you changed the 3 zots, until you get a brand new comparison, okay? Where it's squigs and grozels, no zots. All right, now on to 26, right? It says 20 boxes are being packed into bags. Each box weighs 400 grams. Each bag can hold a mass of up to 1.5 kilograms. What's the smallest number of bags you need? Now it mentions that you have 20 boxes that can fit into the bags. Now it says each bag can hold up to 1.5 kilograms, meaning it could fit up to a maximum of 3 boxes, So one bag can have 3 boxes, but you have 20 boxes, right? Now, why is it not 4 boxes? That's just because 1.5 kilograms is 1,500 grams, and 1,500 grams, right? It is less than 4 boxes, or 4 times 400, which makes 1,600 grams. So therefore, you can only max it out at 3 boxes. So now you can divide it, right? One bag is 3 boxes. So how many bags do we need to make 20 boxes? Well, it's dividing each side, right? Or seeing how much you have to multiply. So if I decide to times by 6, it's not enough. It's only 18. times by 7, it's 21, which is too much, right? So it's timesing by 6 and a fraction, right? Now, why do I not bother finding out the fraction? Well, I know that if I have an extra fraction, that's not enough. I need a whole new bag. So it's going to be 6 plus an extra 1 to cover up the fraction, giving you 7. And so that's why the answer is D. All right, on to 27. Right, for question 27, guys, it's saying, what should the picture graph show for Susie? Right, so that's our goal, to see how many tires we need for Susie's. And they also show us the amounts of Phil's versus Susie's in a column graph, right? Now, although they don't give you numbers, what you need to see is their relationship. How much of Phil do I need to reach Susie? Now, we see that there is an extra little bar that you need to reach the top. And that bar is actually worth half of Phil's, right? So therefore, we know that to get from Phil to Susie, it's as if I get 1 of Phil and I add an extra half of Phil's, and then I can get Susie. So it's 1.5 of Phil's. Therefore, whatever Phil has, we need an extra 1.5 of it. All right. So now we look at Phil's tires. How many tires does Phil have? Right? How many tires does Phil have? So you can work that out by adding it up. So he has one of these symbols. Full tires is worth 4. So it's 4, 4, and he has half. So it's 2. So add that up, that is 10. So since Susie has 1.5, it's 10 plus half of 10, which is 5, which is 15. So you need to look at the option out of all of these, which one adds to 15, right? And your answer here was going to be E, right? So you just had to trial and error this one, times out each of them, and see which one adds to 15. Now E, 3 tires, 3 times 4, 3 full tires, so 3 times 4, and you have 3/4 of a tire, which is 3. So that adds up to 15. Okay. For question 28, now these are the combinations questions. Now you got 6 kids, A, B, C, D, and F. Now all of them need to play a game with another student, right? Now if I start off with A, and A has how many people to pick? 1, 2, 3, 4, 5. A has 5 people to pick from, and A's played with each of them once. What about B's turn? Well, B's already played with A. So B has how many to pick? 1, 2, 3, 4. For C, C's already played with A and B. So C has D, E, and F left. D has how many left since he's already played with A, B, and C? Well, 2 more, E and F. D hasn't played with them yet. So that's 1 and 2, all right? So it's 2. And E's already played with the previous 4 students. E only has F to play with, so that's 1. And when it's F's turn, F goes, I played with everyone already, the other 5 kids. So 0 left. So those are the total matches each of them have left to play, right? After A has gone through with B, B's got C, D, and E left. After C's gone through A and B, C has D, E, and E and F left, etc. So you add up all those matches left, you should get 15. Okay. And moving on to question 29. So again, these jumps, guys, for these number line questions, it's very tricky since we have to work out what each notch here should be worth, right? Now we know that to find out what one notch is, you need to see how many notches make up the total distance from each number to each number. So from 8 to 9, that's the same as 1, 2, 3, and 4 jumps. So what is worth is 1 as a value, right, is worth 4 jumps. So 1 jump is 1/4. The value is 1/4. So this should be 8 1/4, 8 2/4, 8 3/4, and eventually you reach 8 4/4, which is 9. Okay. Now the question says you're moving 11 of these jumps. So 11 jumps means it's 11 times 1/4. And when you're timesing, right, when you're timesing a whole number to a fraction, it's the same as that whole number over 1 times a fraction, which is 11/4. Now to see where we are, if we started from 9, you need to subtract 11/4 from 9. And when we're subtracting 11/4 from 9, you can't subtract a fraction from a whole number. You need that whole number to be a fraction as well. When you're making it a fraction, you put it over the exact same denominator as the other side, 4. And what is the numerator? It's just the bottom number times the whole number, which is 36. And you'll see it makes 9 when you divide the top and bottom. So 36 minus 11/4 is 25/4. And since the answers are in mixed fraction form, you just divide the top and bottom to see what your mixed fraction would be. So 24 can go into 25 6 times with a remainder of 1/4, giving you 8. Okay. Moving on to 30. So for question 30 here, guys, this one, it has an extra table to confuse you. So you got to read what, especially if there's times involved, you got to pick out parts of your table correctly, depending on the information. So guys, how do we know like how much time they spent? It means you would have had to know what time they arrived, then how much time they spent until they left. So working out those 2 times, right? When they came and when they left. Now they told us that they left 4-star. So you want the option, look at the graph where they started off at 4-star. They got on at 8:50. So you're looking at this column, right? Each of those times tells you when they stopped at those stops. So by the time they got to Coffs Harbour, it was 1:39. They arrived at 1:39. But when it came to leaving, so now we're looking at Coffs Harbour back home to 4-star. They got home at 9:19. So it means you're looking at this portion of the table. So since they got home at 9:19, we need to see what time they would have started at Coffs Harbour, which is 4:25. Okay. So now you just need to work out the time between the amount of hours and minutes between these 2 times when they arrived and left. Right. So from 1:39 to 4:25, what you could do is work out 1:39 to 2 p.m. So how many minutes you need to get to 2 p.m. And that's 21. Since if we add 21 to 39, that gets you to 60 minutes. And that's an extra hour you can add to the 1, which gets you 2 p.m. And then from 2 p.m. to 4:25, 2 to 4 is 2 hours. And there's an extra 25 minutes from 4 to 4:25. So now it's 21 minutes plus 2 hours and 25 minutes, which gets you 2 hours and 46 minutes. So just be careful when you're dealing with these questions with multiple graphs and tables. You need to read the information to see which portion of the tables are you working with. Otherwise, you're going to waste your time or incorrectly use the information. 31, these 2 people, Brian and Yaram, have 250 cards altogether, but Yaram has 18 more than Brian. How many does Yaram have? So with these questions where you have unknowns, you need to start off with a number sentence. Y and B, together they have 250 cards. Now, if you remember that apples and banana question, if you have combinations like this one, and to find out what if you're comparing them, or if you're working out what each of the values are, turn your combination so that's all in terms of one quantity. So all Yaram or all Brian, all Ys or all Bs. Now to do that, you need an extra clue. And this clue mentions Yaram has 18 more than Brian. That's the same as saying Brian needed to add 18 to reach Yaram's. Since we know what Yaram is in terms of B or Brian's, I can get rid of this. So now it's all Brian's. So Brian plus 18 is Yaram. And there's an extra Brian there. And now this number sentence is all in terms of Brian and numbers. Bring all the numbers to one side. So instead of plus 18, it will minus and add up how many Brians you have. So it's 2 Brians now. If you brought the 18 over, it's 250 minus 18, which is 232. Okay. Now to get what Brian is worth by themselves, it's 232 divided by 2. You half it. It's 116. But we don't want Brian, we want Yaram. So now you can replace what Brian is, the B, with an actual number, since you just worked out Brian's number of cards. So to get what Yaram is worth, you bring the 116 to the other side and take away that from 250. So instead of plus, it's minus. You get 134. C. Okay. All right. So once again, for these kinds of missing number questions or combinations questions, make the combination in terms of one missing thing only, or Brian's or all Yarams. For question 32, all right, now you need to see how long each of these 2 people take in order to chop up vegetables. Now, if you work out the times, you'll find that the Ramesh takes 40 minutes and Lucinda also takes 40 minutes. So therefore, if they both work at the same time on Saturday and they start at 8:35, all you have to do was add 40 minutes. Okay. So if you add those 40 minutes, so you could add 8:35, and then you add 25 minutes to reach 9 o'clock. And from 9, you have an extra 15 minutes left to reach 40 minutes. So your answer should be 9:15 a.m. C. Okay. All right, guys. So moving on from there now, 33. This one was a bit of a working backwards question, but you had to be careful because there's multiple missing. There's missing numbers in this. They tell you that Monday, Tuesday, Wednesday, Thursday, and Friday, you add amounts in there. And by the end of that Friday, altogether, you've had $80 in total. And they tell you started off on the Monday with $12. But you don't know any of the other days, how much you added in. But what they did tell you is Monday at the end of Wednesday, meaning at the start of Monday. And then if you added an extra amount at the start of Tuesday, and then you added at the start of Wednesday, by the end of that Wednesday, you would have had $30. You already know what Monday is. That's 12. So 12 plus Tuesday plus Wednesday is 30, the start of those days. So on Tuesday and Wednesday, how much should we have added? Well, they tell us Tuesday and Wednesday are the same. So it's the same as saying 2 Tuesdays and 12 make 30, meaning 2 Tuesdays is 18. Tuesday is 9. They tell you Tuesday, Wednesday, and Friday, you're adding the exact same numbers. So that means on Monday, you added 12. Tuesday, you added 9. Wednesday, you added 9. Thursday, we don't know since that's the question, what the question's asking us to find. And Friday, you added 9 to get 80, right? So how much do we add on the Thursday? So 12 plus 9 plus 9 plus 9, that should get us $39. So something added to 39 gets you 80. And if we minus 80 by 39, so take away 39 from both sides, you're left with $41 that you added on the morning of Thursday. So that's E, okay? All right, so that's going to be it for 33. 34. Now for this, they want us to find how many sides there are in the 4 pieces of shapes that we've got after making those 3 cuts. So this is piece 1, piece 2, piece 3. All of them are triangles. And in the center, you have a big block. So you need to work out how many sides there are there. So you measure it up. 1. Notice how every time our cut touches the shape, it creates a new corner for my inside block. So be mindful of that. It's 1 side. 2, 3. Now that's another, where that touches that side, it creates a new corner, meaning that this tiny little side counts as 1 as well. So far we've reached 1, 2, 3, 4. Again, 5, another mini side, 5, 6, 7, counting that mini side at the top. And now finally 8. So it's 8 sides for my big shape in the center. Then I have 3 triangles. So it's 8 plus 3 plus 3 plus 3, which gets me 17, okay? And finally, to wrap things up, we have question 35. Now for 35, there's a map, there's directions, but there's no calculations involved. Instead, they want us to find the greatest number of regions we could pass through from Tamworth to Brisbane, but only moving north and east, right? Now, the trick with this question is, since you want to cover more regions, the space they move should be smaller and smaller and smaller. So therefore, each region that they pass through, you want to pick the really small ones, because the smaller those regions are, the more regions you have to cross, right? If you look at Tamworth, you have to go through only 2 regions, right? Only 2 regions that are tiny. Oh, sorry, that are really, really big. But whereas if you look on the other side, if I draw the exact same length, I touch through way more regions. So it's most likely that you're starting off moving east. Now, if you decide to move east from this point, guys, you'll reach Birrippi, right? And if you keep going up, right, you'll go through 1, 2, 3, and then 4, right? So altogether, we've went through 5 regions already. But here's my problem. You want the most. So now you look at the options and see, is there a way for me to get 8 or 7? Yes, depending on where you stop as you move east. So if you stop here, you get the opportunity to cross to Dengari, even that tiny little crevice. Then you can cross through Nangaye. Then when you go up, you touch through Gumbai Nagir. Then you go up again and you touch Nagarabao. You go east to reach Bunjalang, and then when you go up Bunjalang, you can go to Bungaram and Yagera. So how many regions was that? You go 1, 2, 3, 4, 5, 6, 7, and then 8. But the question says we can't include Yagera. So therefore 8 minus 1 is 7. And that's going to be it from our questions. So it seems like there's no further questions. Our enrollments for term 3 are opening. So if you do plan to continue our preparation with Alpha One for selective, or you just want to get ahead of school, then our WEMT classes for year 5 are opening. So you guys can join those. Alternatively, right, if you have any friends or family who are older, then you have the then of course they can join, or if they're in the same grade, they can enroll for WEMT or our selective trial test courses as well. Some of you guys would have done that already. So instead of learning the foundations, you'll be applying it by doing tests every week. Okay, so if you guys want to inquire about joining in, please call up the office or message them on WeChat or email, giving them a phone call or filling out the form, all right, on the website. So thank you for staying throughout this webinar, guys. It's been a blast teaching you. Take care, guys. Enjoy your holidays and good luck in your preparation for OC. All right. Bye, everyone. Take care.